Today's problem is binary search. So as soon as you understand or hear binary search, simply it means left, right, and mid. Just make sure about it. Because the binary, if you have ever heard of binary tree, it simply means left or the right side. Left is the smaller part, right is the greater part, we can say. But here we have two catches that we have to ensure and be known about. First is if in this array, the array is sorted, they will provide us an element k, which is provided here, and we have to return the smallest index of it. So this is the first part that we have to ensure while writing our program, that we have to return the smallest index. And if we do not find anything, in that case, we have to return -1. So after noting down these 2 points, there will be some sort of changes we can say. And why I'm telling you this, so I'll just first write the code and then I'll show you. All right. So as it's binary search, so as I've said before, I'll simply create one variable, not one actually, three or four maybe. So let's get started. Uh, Integer left for our left side, right for the right side of array. It will be the size of array -1, and we have mid here. We'll make it 0, and our result. So I'll just make the result -1. Why I have made it -1? So we can fulfill this condition. So if we do not find anything, in that case, we'll return the default value of result and it will be all good. All right, let's get started. Okay, so for binary search, we'll just simply put the condition while left is smaller than or equal to right. So we are using a while loop, and the condition here is until it is the left side is smaller or equal to the right side, we can continue the loop. Otherwise, we'll make it stop. Okay. The first thing what we will do is we will assign the value of mid, as we have already got the value of left and right. We have to assign the value of mid. Mid could only be assigned inside because will keep on changing the value of left and right inside the loop. So mid will be assigned inside only. So we'll put mid equal to, it's very simple. I'll explain it to you how it works. So left plus, we'll open bracket, right minus left divided by 2. Now you must have questions like why we wrote this exact thing. I'll explain it to you. Let's say in between for starting also we can say, so for the starting point the value of left is 0 and the value of right is, let's say for this array only, uh let's say this is the array 5. Okay, and we have made it -1, so 4 divided by 2. Okay, so it will be 2. Index will be 2. So that comes in between. All right. So now let's say this is done. After this, we'll go on the right side, let's say. Okay. So for that case, what is going to happen is now the left will become 33 and 55. So the index will be 3 and the right part. Okay. So 3 plus 5 minus 3 divided by 2 So it will be 5. So that will come as this index, the last part. All right. So I'll just remove this for now. We'll continue on our binary search. Okay. So based on that, we'll see if the element of array mid double equals to your search element, that is k, then what we have to do, we have to put the result here as how much? The mid. Okay, so this is the index. All right. Now after this, else let's say the other condition is if your uh, array of mid is smaller than k. Okay, that means it is smaller. Uh, we could say the element that we have found is smaller. It's on the left side basically of the searched element. In that case, what we'll do, we'll have to move the right part of array. We have to move the right bound to the left side. Okay, so how we will do that is so basically here what we are going to do is, as we can see, if array mid is smaller than k, that means we have to move to the k side, and the k side is on the writer side, we could say, right? So we'll go to the writer side, and how we'll do that is we'll move the left. Left, how we will make it? Left equal to mid plus 1. That simply means that whatever mid we have got, we have to move it to this side. And plus 1, why we are doing is because this element is already checked. So we have to move to this side. So hence we are making this statement. And the only third condition left is right equals mid minus 1. Because mid you have already checked, and now you have to move to the left side. Okay. So if we could say array is greater than k, in that case we have to move to the left side. Okay. All right. So this part is done. Based on that, whatever result we get, we will return the result. And while returning it, we have to check one thing, as I have told earlier. If there are multiple references, then we have to return the smallest index. So this will make a little bit of change. So whenever we find the result, let's say we have found it. For this case, we can say in the first index, in the first loop or in the first progression, we'll find 1. But the index of 1 will be 0, 1, 2. But the smallest index is 1, right? So the output is, sorry, 0. So the output is 0. But we will get this index as 2 and it will come as result. Wait, I'll show you. Okay, so this is another condition. The program is taking a bit longer time. So this is like we can say a part of this compiler. So we'll simply make uh, right equals mid minus 1. So basically with this, what we are asking the compiler is if even if we have found the result, let's check it on the right, on the smaller side again. So let us see if that works. Okay, so we'll just submit this and see if the result is good. All right, so we are good to go. Thanks for watching.